Hey Year 11 and welcome to the next episode of Mathematical Mowbray Movies. In this episode we're continuing on with our work on trigonometry, or more specifically on SOHCAHTOA. So I really hope that you kick some solid goals in this episode with your work. There you go, corny joke done. Let's get on with the maths. So here's just a quick review of what we mean by SOHCAHTOA. It refers to sine, cos and tan, and we established what each of those ratios referred to in our previous video. Go back and have a look at that if you're unsure. What you're going to be asked to do with SOHCAHTOA is perform two types of calculations. Obviously they can be more wordy or have diagrams, but simplified, these two types of calculations are either ones that involve calculating an unknown angle. So that would be something like this, where you're given a theta rather than a particular value as your angle, and you're asked to calculate that using sine, cos or tan. In this case you'd have to be given two of the sides in order to do that. So you'd have to be given two of the sides. So you can see in this case I'm given 3 and 4 and asked to calculate theta. The other type of calculation can be that you can be asked to do is to calculate the length of an unknown side. So you can see here I'm given the angle. I'm not asked to calculate the angle, I'm asked to calculate a side. This type of calculation can only be performed if you are given another side, so given one of the sides, and an angle. That's not the 90-degree angle. Okay, so they're the two types of calculations you can perform. Now this video is focusing on this one, calculating an unknown angle when you're given two sides. So let's have a look at the steps involved in doing that. The first step in any of these questions is to label the sides. If you have to draw a diagram, that would be a step before it, but oftentimes the diagram's given. So you label the sides, opposite, hypotenuse and adjacent. Then you're going to work out which ratio you'll use. And to do that, of course, you're going to use SOHCAHTOA. Once you've worked it out, you're going to write out that ratio. So by that I mean you're going to write out sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, whichever one it is that you're going to write out. Then you're going to substitute the values from your question into that formula. Finally, you're going to use the inverse function on your calculator, and I'll show you that in just a moment. So let's have a go at this first question. Here's my angle that I'm trying to work out. You can see that it's calculating an unknown angle because I've got the theta there. And as needed, I'm given two sides. I need to begin by labelling those sides. So let's have a look. This 7 here refers to my hypotenuse because it's the longest side. And this 3 is clearly opposite my angle. So I'm interested in the ratio that involves opposite and hypotenuse. I'm interested in the sine ratio. So I've done step 1 and 2, worked out which ratio to use. I'm going to write out the ratio and then substitute step number 4. The ratio I just said was going to be sine, so I write out sine theta equals opposite over hypotenuse. Then I substitute in the values I know. I don't know anything about the angle, that's what I'm trying to work out, so that stays the same. But I know that my opposite side is 3, so I replace opposite with 3. I know that my hypotenuse is 7, so I'm going to write that in there. Now I'm trying to find theta here. So in order to find theta, I need to get rid of this sine, and to do that I use what's called the inverse sine function, which is sine to the minus 1. So on my calculator, I'm going to type in sine to the minus 1. Now you'll find all the inverse functions, sorry, can you see that? Just above your sine, cos and tan buttons, and they're accessed by pressing the second function button. So I'm after inverse sine. So you can see that I've got sine to the minus 1 on my calculator. Then of course you're going to enter the fraction, 3 over 7. Now my calculator is a little bit different to yours. I enter it like this, but you'll enter the fraction as you do normally and press equals. Now you can see here that this has given my answer as 25.3769 and so on. If I want that in degrees, minutes and seconds, I don't do that. Let me just do that again, sorry. 3 over 7. If I want that in degrees, minutes and seconds, then I'm going to press the degrees, minutes, seconds button, but the second function above that, and that's going to turn it into degrees, minutes, and seconds. So just again, as the decimal, this was 25.376 is going to round up to 38. But oftentimes I'm asked to give my answer in degrees, minutes, and seconds. So I press second function, degrees, minutes, seconds, and this is 25 degrees, 22 minutes, and because it's 36 seconds, there's 60 seconds in an hour, and there's 60 seconds in what we'd call, 60 seconds in a minute. So it's going to round up because it's closer to the next minute. So this is 25 degrees and 23 minutes. All right, let's have a look at the next one here. So first of all, I have to label the sides. This is my hypotenuse, so I don't need to label that because there's no number there. This is my opposite side because it's opposite the angle. This one is adjacent to the angle. Which of my ratios involves opposite and adjacent? It's going to be my tan ratio. So step number 3 says, write out that ratio. So I'm going to write tan of theta equals, I'm just writing it exactly as it is, opposite over adjacent. Now I need to substitute in what I know. Well, I don't know anything about this bit yet, but I know my opposite side is 10. I know my adjacent side is 4. So I'm going to write 10 over 4. Same thing as before, I need to use the inverse function. This time I'm going to use the inverse of tan. So it's going to be 10 to the minus 1, 10 over 4. So again on my calculator, I'm going to press second function 10 to get 10 to the minus 1 on my calculator. I open brackets, type in that fraction, 10 over 4, close my brackets, 68 point, you can't see the 6 there, 68.19859 and so on, if I'm writing it as a decimal. If I want to convert that, so I could write that, if I was writing that out, I could write that as 68. Now this one again, if I was writing it to 2 decimal places, this wouldn't be 0.19, that 8 pushes this 9 up, and as soon as that 9 jumps up, that's actually going to bump on and push this 1 up. So it's actually going to be 68.20 degrees. But if I wanted to write that as degrees, minutes, and seconds, I'd press second function, that button, and you can see that it rounds to, can you see there? 68 degrees. Now it's 11 minutes, but again it's 54 seconds. Well, 54 seconds is pretty close to 60 seconds, so it's actually going to round up to 68 degrees and 12 minutes, because we talk about degrees, minutes, and seconds. Alright, so here's a question for you to have a go at. Calculate the size of the angle theta in this particular question. So have a quick go at doing that calculation. Alright, hopefully you've had a go. I'm just going to go through this very quickly. Here's my adjacent side, here's my hypotenuse. Adjacent and hypotenuse means I'm going to use cos theta equals adjacent over hypotenuse. Cos theta then, adjacent was 6, hypotenuse was 12. Using my inverse function, oops, you can't really see what I'm doing there. The inverse function of 6 over 12. Cos 6, I'm just typing this in here, 6 fraction 12, close brackets, gives me spot on 60 degrees. Okay, hopefully you got that one correct.